Sometimes we have algebraic integrals whose solution are of the form of our inverse trig functions. If I had the integral of du divided by the square root of a squared minus u squared, this is the inverse sine of u over a plus c. Similarly, if I have the integral of du divided by a squared plus u squared, this is 1 over a times the arctan of u over a plus c. And finally, the integral of du divided by u times the square root of u squared minus a squared. This is 1 over a arcsecant of the absolute value of u divided by a plus c. Now a couple of things. We're going to let a equal positive. Now, if I had a negative in here, I would just factor it out. We're not going to work with the inverse, the solutions where you have the inverse cosine, inverse cotangent, inverse cosecant. Now to do these problems, what I want you to do is to identify the form. So this is of the form of the integral of what? The inverse tangent. Du divided by the square root of a squared minus u squared, all right, is equal to, I want you to go on and write the integral down. So this is the inverse sine of u over a plus c. And I guess you don't need that equals right there. I just want you to put the form on there. So just put the form, the integral du divided by the square root of a squared minus u squared equals inverse sine. All right, because I want you to come down here now and identify all the forms of the equation. Now let's start, always start with what u is. U squared is x squared, so u is x. A squared is 4, so a is 2. Remember, we're always going to take the positive. If u is x, du is dx. Now translate this back into your u form. Oh, I'll do it down here. So this becomes the integral. Dx is du divided by the square root of a squared minus u squared. And my solution is the inverse sine of u over a plus c. Now I know this seems a little redundant for this problem because now we have to multiply, substitute back in. So this is the inverse sine of x over 2 plus c. But we're going to see it's not always quite this straightforward. What if I have this function right here? This is of the form of the inverse tangent. So I know the integral of du divided by a squared plus u squared is equal to 1 over a, the inverse tangent of u over a plus c. All right, so now let me come over here and find u. U squared is 9x squared, because you always take the one that's got the variable in it. So u is 3x, and du is 3 dx. So I'm going to solve this for dx. Dx is du divided by 3. Now let's find out what a squared is. A squared is 2, so a is the square root of 2. Now let me plug all of this back in to my equation. This becomes the integral. Dx is du over 3. So I'm going to pull that 3 out here. Divided by, okay, this is a squared plus u squared. And so my solution is 1/3 times. Now, this is 1 over a times the inverse tangent of u over a plus c. Now I'm going to plug back in my variables. This is 1/3. A is the square root of 2. So this is 1 over the square root of 2. This is times the inverse tangent of u, and u is 3x, divided by the square root of 2 plus c. So my answer is 1 over 3 square roots of 2 times the inverse tangent of 3x divided by the square root of 2. Now for this problem, I can see it's of the form of the inverse secant. Now I know, now I'm writing it down so I'm going to change colors for this one. Now I know the integral of du divided by u times the square root of u squared minus a squared is equal to 1 over a times the inverse secant of the absolute value of u over a plus c. So let me break this up. This is always going to be u squared. So u squared is 4x squared. So u is 2x. Du is 2 dx. So dx is du over 2. Took care of that. Now a squared is 9. So a is 3. Now I'm going to take all of this and I'm going to change colors. Let me go to red. And I'm going to plug these into my original equation. So this becomes the integral. dx is du over 2. So I'm going to put this 1/2 out here. Divided by, now x. I didn't solve this for x, but it's pretty obvious that x is u over 2. I should have done that. So this is u over 2 times the square root of 4x squared is u squared minus a squared. Now I'm going to rewrite this. Look at what happens to these 2's. So those are going to cancel. So this becomes the integral of du divided by u times the square root of u squared minus a squared. And this solution is 1 over a inverse secant, the absolute value of u over a plus c. Now I'm going to plug in. A is 3, so this is 1/3 inverse secant, the absolute value of u, so the absolute value of 2x divided by a, and a is 3.